Welcome to the pre-calculus video for skill number 4. I can use and apply the standard form equation of the circle in the Cartesian plane. And the trivia question of the video is, of what mountain is this a map of, and what type of map is shown? Alright, we'll start our notes on page 4a, and I'm going to give you two forms of the equations for circles. The standard form is the easiest to use, and that is in the form x minus h quantity squared plus y minus k quantity squared equals r squared. And when we see an equation in that form, we are able to find that the center of the circle is located at h comma k, and that the radius is r. The second form is called the general form, and we use that less often because it's difficult to connect it to graphing, though we can. And that will fall in the form of x squared plus y squared plus ax plus by plus c. On the skill test for this video, or for this skill, we will need to know how to convert from this form, the standard form, to the general form, but we do not need to know how to go in the opposite direction. We also need to know how to look at an equation and find this information so we can graph it, and we should know the reverse. Look at this information or a graph of this information to write the standard form of the equation. So let's take a look at the first example. What we have is graph the equation x minus 3 quantity squared plus y minus 2 quantity squared. So looking at the equation, I find that I have a center located at 3, comma 2. So I plot my point at 1, 2, 3 units over and 2 units up. And then the radius is given as 25, which is 5 squared, so our radius is 5. So from that center point, I can count out 5 units. 1, 2, 3, 4, 5, and I draw my circle along there. I like to count 5 units in each direction all the way down so that I get 4 points on the curve. I did not make enough room for myself to draw the full circle, but yes, it does continue up here. This one is a pretty easy problem because there's no negative signs in there. When we get negative signs, it gets just a little bit more difficult. So let's look at that in example 2. Example 2 asks us to graph x minus y quantity squared plus y minus 2 quantity squared equals 9. So we can find that our x coordinate for our center is located at 1, and then the y coordinate is located at negative 2, because what we really have is y minus negative 2 quantity squared. So that's how we get the negative 2 value. And then the radius would be taken from the 9. The square root of 9 is 3. So then we plot our center 1 unit over and then 2 units down. There's the center of our circle, and then we have a radius of 3. So we count out 1, 2, 3 units, 1, 2, 3 units, 1, 2, 3 units, and 3 units. Drawing our circle. Pretty straightforward. In example 3, we're going in the opposite direction. Given the graph, write the equation of the circle in standard form. Also write it in general form. So let's start by writing this in standard form, which I've shown here. We take a look at the drawing of our circle and notice that the center of the circle is located at negative 1, negative 2, negative 3, negative 4. So it's at negative 4, comma 1, 2. Negative 4, comma 2. And then we can also count our units and find that the radius of the circle is 4. It's kind of difficult to see in this drawing. on the skill test there will be a grid, and it'll be, of course, much more cleanly drawn. So our standard form of the equation is x minus h quantity squared plus y minus k quantity squared equals r squared. So we plug in these values. -4 goes in for h, and 2 goes in for k, and then 4 goes in for r. From there we clean it up just a little bit, and we get x plus 4 quantity squared, y minus 2 quantity squared equals 16. So there's our standard form of the circle drawn here. If we want to write this in general form, it's more or less just a process of expanding and then combining your like terms and moving everything all around so that it fits the fashion of the standard or the general form. So here's our equation as written above, and then in the first step I expanded, so x plus 4 squared became x plus 4 times x plus 4, and then I used distributive properties. X times x is x squared, x times 4 is 4x, 4 times x is 4x, and 4 times 4 is 16. Then I simplify that down to x squared plus 8x plus 16. I did the same thing for the y minus 2 squared. Y minus 2 squared, expand it, distribute, clean it up. And then in the last two steps, I am taking all of my pieces and writing it into the standard general form, the general form. And as a reminder, the general form looks like x squared plus y squared plus ax plus by plus c equals 0. So we've got the x squared, the y squared, 8x minus 4y, and there's our c value is 4, equals 0. A good challenge question for those high achievers wanting to challenge themselves: can you take an equation that is in the general form and move it into the standard form if you're just given the equation? And the process, it does exist, and I'll give you the hint that it uses completing the square. Beyond that, I'll leave you to your own creative endeavors. Alright, the final example says graph y equals the square root of 16 minus x squared. And at first you're like, what does this have to do with circles? It looks nothing like circles. But I assure you that this is very closely related to a circle. It is in fact a semicircle. So I will pull this up and let's explore it. I'm going to tell you it's a semicircle at the origin with a radius of 4, and that it's the top half of the circle. So let's just prove that this is true. And you won't have to do this proof, but I just want you to be able to recognize that this type of equation is also related to a circle. So if it's centered at 0, 0, we have plug in 0 for h, 0 for k, and if it's got a radius of 4, we plug in 4. X squared plus y squared equals 16. If we solve this equation for y, we would wind up having y is the square root of 16 minus x squared, or more specifically plus or minus, which means the plus version, which is what we're graphing, is the top half of a circle, and then the minus version, minus root 16 over x squared, is the bottom half of a circle. Okay, isn't that like a Pokemon ball or something? Alright, so the conclusion we can draw is we can say that if we have two equations, or if we have an equation in the form of y equals root number minus x squared, that is a semicircle. More specifically, a semicircle with radius r, and it's centered at the origin. And it's the top half of the circle. And the negative one is the bottom half. Alright, thanks. Thanks for watching the video. The skill again was I can use and apply the standard form equation of the circle in the Cartesian plane. And the map featured below, if you look closely, it says Mount Hood. So this is of Mount Hood, just outside of Portland, Oregon. And the type of map is a topographical map.